Hi guys, you welcome back to my channel. Today we'll be looking at volumetric analysis for the 2026 Waec examination. Now, A is a solution containing impure, please take note of this, impure tetraoxosulfates containing 4.0 or 5.0 gram in 250 cm cube of solution. B is a solution containing pure 4.0 gram of sodium hydroxide. Put A into the burette. This is our A. Please. This is our A. Put A into the burette. Here is we have the burette here. And titrate with 20 cm cube or 25 cm cube portion of B using methyl orange or phenolphthalein as the indicator. Now, you have to take your reading. So, calculate concentration of B in mole per dm cube, concentration of pure A in mole per dm cube, concentration of pure A in gram per dm cube, number of hydrogen ion in 1 dm cube of A. Calculate the percentage of purity and impurity in solution A. So respectively, both A and B, that is, you have to calculate the percentage of purity A and impurity. So guys, let's take a look at how we can carry out the practical. Here is our AN and here we have our BN. So this is part of the AN and part of the what? The BN. So guys, you have to fill in these burettes or to get to this meniscus, please. So be careful. So the moment you fill in the acid into the burette, you remove the. Now we have this. So pick one of these conical flaps. Now here is our methyl orange. You know, I made mention that either we make use of methyl orange or phenolphthalein. So if time permitted, I will drop a video using phenolphthalein. But for those of you using phenolphthalein out there, you've been having a clear solution. Now, so let's take a measurement of this. Please and please, if in your school you have this or you have this pipette and this measuring cylinder, they can serve the same function. Is that clear now? So I'll be making use of this now. I have measure 25. So you pour it into these conical flask. Then you take 2 drops of methyl orange. The first one. Also have another one. So now, so the moment we have this, take it to this place. So you release until you have, if you can see, we have change in coloration. Are you seeing it now? So we have, guys, what do you have here? The color is what? Orange. Now, at this place, we are having 12. Is that clear now? If you take a look at the video I dropped yesterday, so the rough title, I have 12. So if you take a look at the video I dropped yesterday about endpoints, this is how you can easily deduce your answer. Now, the next one, you refill your burettes. So you remove this. Take another measurement of the base. $25, don't forget. I have this. First drop and the second drop. Now So let's be careful. So let's have something similar to what we have earlier. Okay, I have 12.2. So this is the first and the second. I have 12.20, 0.00. So the next one. So I have to continue from this place, 12.20. So, but to be on a good side, so we're having a good accurate value, I would advise you to refill the bullets. So, so you measure, when you measure it, we have 25. So here is another, the third conical flag. So 1, I have 2. So just keep shaking until you have your end point. We're having, okay, for this, I have 12.30. This is for the second item value. The initial, we have 12.30. So let's take the last one. So you take a measurement of the base. You have this. So the first drop and the second drop. So don't forget, you have to refill your bullets. So, okay, have more clear space. Okay, I have 12.40. Now we are done with the volumetric analysis part. So we have 12.40. 12.40. So if we are to calculate, we said the average volume of acid use. So that will be the first, second, and the third. We have first plus second plus the third divided by what? 3. Now, what is the value of the first one? So I have VA, we're having 12.20 plus 12.30 plus 12.40 divided by 3. So I have 12.20 plus 12.30 plus 12.40 divided by 3. So we have 36.90 divided by 3. And our answer, we have 12.30 cm cube. Now, back to the question, we have to calculate the concentration of B in mole per dm cube. So in that case, we said B is a solution containing pure 4.0 gram dm cube of sodium hydroxide. So to calculate this, I have one. So we said sodium hydroxide for the B. So calculate this molar mass. And for you to have it in mole per dm cube, we said you have molarity equal mass concentration over molar mass of B. Now, what is the molar mass of B? NaOH is equal to 23 plus 16 plus 1. We have 40 gram per mole. The mass given is 4. So we can easily say molarity is equal to 4.0 divided by 40 gram per mole. And here we have gram per dmq. This we cancel this. So we have molarity. So we said 4 divided by 40 is 0.100 mole per dmq. That is for the first one. The second one, concentration of A in mole per dm cube. So before we can calculate that, I will advise you to know the equation to use for this type of reaction. Now, mind you, we're having sulfuric acid SO4 plus sodium hydroxide 2 mole. That will give us Na2SO4 plus water. Now, this is the equation given. How can we calculate the pure A in mole per dm cube? We can easily say we have number 2, Ca Va over Cb, Vb is equal to Na over Nb. Now, what is the number of mole of the acid? We have 1. For the number of mole of the base, I have 2 here. So our Ca, which is the concentration of the acid in mole per dm cube, it is what we are asked to calculate for. Are you there? So we can say Ca, we don't know it. Our Va, the average volume is what? 12.30 cm cube. Are you there? So our Cb is what we have here. 0.100 mole per dm cube. Our Vb, the average volume of the base used here earlier when I was showing the titration, is 25. Is that clear? So I have 25 cm cube. Some tutors might choose to make use of 20 cm cube, but I'm using 25 cm cube. So what our Na is 1, our Nb we have 2. So we have to make this Ca the subject of formula. By doing so, we can say we have Ca Va Nb equal Cb Vb Na. So the coefficient of Ca is Va Nb. I have Va Nb. This we cancel this. So we have Ca equal, what is the value of Cb? 0.11 times our Vb is 25 multiplied by 1 over Va is 12.30 multiplied by 2. So Ca equal 0.100 times 25 times 1. So I have 2.5 over 12.30 multiplied by 2. I have 24.60. So in that case, we can say we have 2.5 divided by 24.60. So I have 0.102 mole per dm cube. Now that we are done with the first and the second calculation, so they said concentration of pure A in gram per dm cube. So guys, I'm going to clean these parts. So we have concentration of A in gram per dm cube. So by doing so, we can say we have mass concentration equal molar mass multiplied by molar concentration. Now, what is the molar mass of sulfuric acid? H2SO4. So I can say 1 multiplied by 2 plus 32 plus 16 times 4. So in that case, we can say we have 2 plus 32 plus 16 times, this is what? 64. So we have 98 gram per mole. So guys, for us to find the concentration of A in gram per dm cube, what is the value of A? For the acid, we have molar mass. You can say mass equal, the molar mass is 98, multiplied by the value you have here is what? 0.1. So times 0.1. So we have 9.99. So when you approximate, you're going to have 10 gram per dm cube. Now, we are done with this. We are done with this. We are done with this. Now, they said number of hydrogen ion in 1 dm cube of A. Now, you have for this, that's question 4. This is 3. So for this now, sulfuric acid, that's the acid. So when you look at this, we have 2 hydrogen ion. Are you with me now? Plus SO4 to negative. So for you to be able to calculate this, there's one thing you need to know. What is the value of the hydrogen ion? That is, the mass count given is what? 0.1. Sorry, the molar count is what? 0.120. Now, we are going to multiply this value. It said 1 mole of sulfuric acid or 1 mole of hydrogen ion is equivalent to what? 0.102. Then what will be for 2 mole? So you can say 2 mole equal 2 multiplied by 0.120. So that will give us 2 multiply 0.120. We have 0.204. But since we are looking for the number, we can say Avogadro's constants equals 6.02 times 10 raised to the power 23. Now, we are going to use this value here to multiply the Avogadro's constant. So in that case, you can say 0.204 times 6.02 times 10 raised to the power of 23. So we have 1.22 times raised to the power of what? 22. That is the value. That is the number of hydrogen ion in 1 dm cube of A is this. Now, percentage of purity and impurity in solution A. So how can we calculate this? So you can say percentage purity is equal to mass of pure divided by mass of impure multiplied by 100 over 1. Mind you, the mass of impure, which is this, we have this 4 gram of what? Of sodium hydroxide. I can say 4.0 gram of sodium dm cube of 250 cm cube. But our target is 1 dm cube, which is equivalent to 1000 cm cube. For us to dissolve the base in that thing, earlier on the video I dropped, so you can say you have 4 multiplied by this, we have 1000 cm cube. That will give us, so we have 4000 cm cube. In that case, this will give us 250 divided by 4000. So that will give us it will be 4000 divided by 250. So 4000 divided by 250. So we have 16 gram. Now, don't forget, we have to look for the percentage of the purity and impurity. So for us to have that, we can say percentage purity equal the mass of pure. This is the value for the mass of pure. We have 10 over mass of impure. We just calculated for the mass of what? The impure. We have 16 multiplied by 100 over 1. Please take notes. So we can say we have divided by 16. So we have the value is 62.50% for purity. This is the value. Now, for us to have the value for impurity, please, I will have to clean this part. So, for us to have the value for impurity, so we can either solve it in two ways. So we can say percentage impurity equal mass of impure, or we said, what's the value we have here? Minus mass of impure, or we can say for impurity, you can say 100 minus the value you have here, which is what? 62.50. So you can say 100 minus 62.50. We have 37.50%. So guys, this is how to tackle a question. And mind you, these are just likely questions we are going to come across in your examination, which is holding next week. So if I am a student or a tutor, this is a step-by-step calculation of volumetric analysis. So guys, I'll be dropping the video on qualitative analysis in our next video. Don't forget to subscribe to my YouTube channel, like, share, and follow us on our TikTok page. Thank you.